the graph of x squared minus 4x plus y squared plus 6y minus 24 equals 0 in the xy plane is a circle. What is the radius of that circle? In order to solve this question, you need to know the circle equation. The circle equation, which is x minus h squared plus y minus k squared equals r squared. H comma k, the coordinates, is the center of the circle, and r is the radius. And so we're after r in this question. Now, there are two ways you can actually solve this question. You can use completing the square, and if you are familiar with that already, I recommend you click out of this video because we're not going to do that. We're going to use another less common method, which is minus b over 2a. And if this rings a bell, you should be able to understand that this is, if I have a quadratic ax squared plus bx plus c, if I have this quadratic, then if I plot it and it's like something like this, well, minus b over 2a is the x coordinate of the vertex, minus b over 2a. And let's say this is f of x, rather. F of x. And so the y coordinate of the vertex is going to be f of minus b over 2a, right? And so that is what we're kind of going to do in this question. We're going to make we're going to segment this circle equation into two parts. And we're going to find the almost a quote-unquote vertex for both of these segments. And those segments are x squared minus 4x, right? And y squared plus 6y. Those are our two segments. And we're going to kind of find the fake vertices for those two segments. Okay, and so if I do that, it's going to be something like, let's say, minus b over 2a is going to be, for this, it's going to be minus 4 over 2 into 1. 1 is, there's an imaginary 1 there. And so this is minus 4 is going to be, it's going to give us 2. And so our first coordinate of the fake vertex is 2. And then now I plug in that value to give the y coordinate. And so that's going to be 2 squared minus 4 into 2, which is minus, it's going to be minus 4, right? 2 squared is 4 minus 8, right? Minus 4. So that is our fake vertex, okay? And if this doesn't make sense, just hang on a bit and it'll make a bit more sense later on. So I'm going to do the same thing over here, minus b over 2a. I'm going to find the x coordinate of our of this segment, and so it's going to be minus 6 over 2 into 1, that is minus 3. So our first coordinate is minus 3. So, and then I'm going to find the y coordinate of this fake vertex. Okay, so minus 3 comma, and that's by plugging in this minus 3 again into this. So it's minus 3 right here, minus 3 squared plus 6 into minus 3. And that gives us minus 3 squared is 9. 6 into minus 3 is minus 18. So 9 minus 18 is minus 9. And so our y coordinate is minus 9. Okay, so we have these two fake vertices. That's what we're after, these two fake vertices. And what you understand actually, and this is the key idea here, is that this 2 and this minus 3 are actually h and k of the circle. This 2 and minus 3 are the h and k. So in specific, because this is the x, and because h is associated with x, this 2 is going to be our h. And this minus 3 is going to be our k. Okay? And so now we can construct the beginning of our circle equation. We could start doing it, okay? And so again, h we can write the center points as coordinates. So it's literally 2 comma minus 3 is our center point, right? And so now we're going to construct the circle equation. X minus 2, h, right? 2 is h, squared, plus y minus 3, that's just plus 3, squared. 3 minus 3 is our k, right? And so that's what we have so far of the circle equation. Now, note, if you haven't already noticed, notice how we haven't included this minus 24 or this minus 4 or this minus 9 into our circle equation. The minus 4 and the minus 9 were our y coordinates of our fake vertices, like I like to say, right? The fake vertices. We haven't included that. So what we're going to do is just simply bring them down and add them at the end of what we have so far. Minus 24, minus 4, minus 9 equals, the main equation is equated to 0, so equal to 0. Okay, again, there's a lot of steps what we have so far, but I'm going to recap again. What we did is that we wanted to convert this equation right here, which is not in this form, this circle equation form. And so the way we did that is through this minus b over 2a, which is usually used to find the vertex of a quadratic equation. But in here, we have segmented our circle equation into two parts. The one most denoted for x, right? X squared minus 4x. And the second part, which is for y squared plus 6y. And with that, we found our fake vertices for these segments. The fake vertex for the first segment was 2 comma minus 4, and the second was minus 3 comma minus 9. The reason why I call it fake vertices is because obviously a circle cannot really have a vertex, right? But these individual parts, the reason why I segmented them, they're actually just quadratics, right? And so that's why I'm able to do this. I'm able to find the vertex points of this. And now, the x coordinate of these vertices, these fake vertices, are the h comma k. They are the center points of our circle. And so now we can reconstruct, and that's what we have so far. And we brought down whatever was remainder of these of this main equation, of what we got from the y coordinates of the vertices as well, and we brought them down. I hope that makes a bit more sense now, but yes, it is a bit confusing, but if you really just practice this and do more practice, you will be able to solve these type of difficult questions very quickly. Continuing onwards now, sorry for the tangent, this is basically very similar to the circle equation now. So I'm going to rewrite and simplify this. X minus 2 squared plus y plus 3 squared minus 24 minus 4 minus 9 is minus 37 equals 0. Notice how there are no constant terms on the left hand side in this equation, and so we want the same thing. We're going to add 37 to both sides of this equation, and so that's going to be equal 37. So this is our circle equation. This is our final. This we have accomplished. We have successfully reached the circle equation form. Okay, so now we can start finding the radius. Well, here, whatever's on the right hand side is r squared, right? So 37 is our radius squared, right? Right here, what I'm doing, I'm just equating these guys. And so our radius is root 37, and that is our answer, C. Yeah, again, as I said, sorry for being repetitive, but this question is quite difficult and it takes a lot of practice to get used to this method. I know I explained it in like 10 minutes, but really, essentially, once you're quick with this method by practice, you should be able to do this within 1 or 2 minutes. And yeah, and so I recommend maybe look through Khan Academy for difficult circle equation questions, or just do some more practice problems, because this is a very common difficult question on the SAT. But nevertheless, our answer is C.